Let's talk about the leading coefficient test, and first let's talk about when we have an even degree with a positive leading coefficient. Here are several examples. First, just a simple one. Notice that we have an even degree, 2 being an even number, and that this is a positive x squared. So a positive coefficient with an even degree. Now, what we're going to gather from the leading coefficient test is what happens on the far left-hand side of the picture or the far right-hand side of the picture. You'll notice that with this even degree and a positive leading coefficient, the left side of the picture is up and the right side of the picture is up. Both sides are pointing toward positive infinity for y. With an even degree and a positive coefficient, both sides seem to point up. Let's see if that's going to be true with a more complex picture. Here is a positive x to the fourth. So again, an even degree, a positive coefficient. The left side is pointing up, so is the right side. Both sides do the same thing, positive and even. They are both pointing up. If we have an even degree with a positive coefficient, both sides are going to point up. No matter how elaborate of a function you create, if you've got a positive leading coefficient with an even degree, both sides of the picture will point up. Here we've got a really fancy one. A positive 4 is the leading coefficient. A 6 is our degree. 6 is still even. And look at what the two sides are doing. Both of the sides are pointed up. So if you've got an even degree, a positive leading coefficient, then both sides will point up. Y goes to infinity for both of the sides. All right, now let's take a look at the leading coefficient test when we've got an even degree still, but this time a negative leading coefficient. Let's take the simplest one. Here is an even degree, a degree of 2, and we've got a negative leading coefficient this time. Now, as we saw a minute ago, both of the sides do the same thing if you've got an even degree. But looks like what they're doing this time, both sides point down. So with an even degree and a negative leading coefficient, both of the sides are going to point down. Let's see if that holds true for a higher degree. Here is a negative coefficient with an even degree, so I'm expecting both sides to be pointed down. Both of the sides do the same thing when we have an even degree, and they are both pointing down. Both sides are pointing y goes to negative infinity. When I have an even degree with a negative coefficient, the two sides point down, which means both sides y goes to negative infinity. Let's see if it's true with a fancy one. Here is a negative coefficient. Here is an even degree. With an even degree and a negative coefficient, the two sides should be pointing down toward negative infinity for y, and both sides are. No matter how elaborate the function is, if you've got a negative coefficient with an even degree, both sides point down, y goes to negative infinity. Let's take a look now at the leading coefficient test, but with an odd degree. If you have an odd degree and a positive leading coefficient, we'll look at that one first. Here, the most basic possible way for us to do this is for our equation to just be an equation of a line. Remember that a line has a degree that is understood of 1, and we do here have a positive leading coefficient. Now let's look at the picture and see what's happened. Looks like this time the left side of the picture is pointed down. Imagine an arrow pointing down, saying that this is going forever down. Looks like the right-hand side of this picture is pointed up. Imagine an arrow pointing up on this side. So here, with an odd degree and a positive coefficient, the left side pointed down while the right side pointed up. In fact, for anything that has an odd degree, you can keep in mind O for odd and O for opposite. The two sides are going to do opposite things if you have an odd degree. With a leading coefficient that is positive, the left will point down, the right will point up. Let's see if that's true with a little bit bigger one. Here I have an odd degree, 3 is an odd degree, and again a positive leading coefficient. So with an odd degree, I expect my sides to do opposite things, and they are. With a positive leading coefficient and an odd degree, the left side is pointed down. It's at the bottom of our screen. The right side is pointed up. It's at the top of our screen. Anytime you have an odd degree with a positive coefficient, the left will be down, the right will be up. The two sides will be opposite of each other. Even for something as large as a degree of 21, since 21 is an odd number, I've got an odd degree here. A positive leading coefficient, just the sign of it matters, means positive and odd, the two sides will be opposite of each other, with the left side pointed down and the right side pointed up. No matter how elaborate the function becomes, if you've got an odd degree and a positive coefficient, then the two sides are going to do opposite things. The left side will be aimed down. It'll be at the bottom of your screen. The right side will be aimed up. It'll be at the top of your screen. Now, the way that you'll have to express this, when we talk about that it is at the bottom of the screen, we say that y is going to negative infinity. When we're talking about it being at the top of the screen, we say that y is going to positive infinity. So for the left side of this picture, y goes to negative infinity. For the right side of this picture, y goes to positive infinity. Anything with an odd degree, the two sides will be opposite. If it's positive, y goes to negative infinity on the left, y goes to positive infinity on the right. Finally, let's look at the last possibility for the leading coefficient test. That's when there's an odd degree with a negative leading coefficient. Now, we saw just a minute ago that an odd degree means the two sides will be opposite of each other. So I'm still expecting O for odd and O for opposite. But now let's see how it changes because of the negative leading coefficient. Again, let's start with just a basic line. A degree here of the line is 1, and notice that a negative leading coefficient, -2, is our leading coefficient. So now as I look at my picture, the two sides are doing opposite things, but this time what's happening? The left side of this is pointing up, y goes to positive infinity, while the right side of this is pointing down, y goes to negative infinity. So the two sides are still opposite of each other, but this time the left side is aimed up, while the right side is aimed down. Anything with an odd degree, the two sides will be opposite, and when it's a negative leading coefficient, the left side points up, y goes to positive infinity, and the right side is pointing down. It's at the bottom of our screen, so y is going to negative infinity. Even with something as large of a degree as 21, if it's an odd number, it doesn't matter how big it is. An odd degree with a negative coefficient, only the sign matters here, a negative coefficient, an odd degree, the left is pointed up, y goes to positive infinity at the top of our screen, the left side at the top of our screen, and the right side is at the bottom of our screen, the right side of the picture, y goes to negative infinity. No matter how elaborate the function becomes, if you've got an odd degree, the two sides are going to be opposite of each other. If it's an odd degree with a negative coefficient, the left side points up toward positive infinity and the right side points down toward negative infinity. Now let's look at some specific examples from MyMathLab where you can see that we can identify the correct picture just from knowing the leading coefficient test and finding the y-intercept for something. As we look at this particular picture, I notice I've got an odd degree here. With that odd degree, I'm expecting a picture where the two sides are doing opposite things. This one has a positive leading coefficient. So with a positive coefficient and an odd degree, I want the left side to be pointed down and the right side to be pointed up. That means only A or C could be our possible choices. The other two don't match the description of positive and odd. Now, how I can determine which one I want, let's blow up this picture. Think about the y-intercept of this. If you put in 0 for all of the x's, then the y-intercept was at -2. So I'm looking for a picture that is down on the left side. I want it to be up on the right side, and I want its y-intercept to be at -2. Looks like this is the correct one. So the choice that we would make for this one is choice A. If you're trying to compare that with choice C, the difference here, we still have down on the left and up on the right like we should, but look where that y-intercept is. It's in the wrong spot. So C is not correct. D didn't work because it didn't have the right direction for the left side and right side. Same thing with B. And C has an incorrect y-intercept. So our choice had to be choice A. Let's look at another one. This one has an even degree. So the two sides should be doing the same thing as each other. An even degree with a negative leading coefficient means that the two sides should point down. Negative with even, both sides point down. Looks like the first two choices are out. Now I'm looking for one of these two choices, either C or D, but they need to have a y-intercept of 12. When I look at the choice C, its y-intercept is way down here in the negative numbers, so that can't be it. As I look at choice D, it's got both sides pointed down. If I were to put 0 in for all the x's, my y-intercept would be at 12. Looks like this is at 12. So it looks like that choice D is our correct choice. Now, one other thing for us to think about, a little bit more complex. When we're using the leading coefficient test, we want to determine which way y is going as x goes to -infinity. Now, when it says x goes to -infinity, that's just a fancy way of saying the left side of the picture. X goes to -infinity is the left side of the picture. So we want to know with an odd degree and a negative coefficient, what's going to happen on the left side. Two sides are opposite of each other, and if it is a negative coefficient with an odd degree, the left side's pointing up. So if the left side is pointing up, that means on the left side, y goes to +infinity.